Namaste students, this is Seema Bhardwaj on behalf of Maths Department. Students, today we will be studying chapter 10, that is circles. Definition of circles you have done in 9th class, and you have studied that set of all points, collection of all points which are at a fixed distance or a constant distance from a fixed point is called circle. If we join various points which are at a fixed distance from a particular point, they are called, when we join these points, what shape is formed? Circle is being formed. This fixed point is called center and this fixed distance is called radius. You have also studied some very important terms related to circle. You have studied about diameter, chord, arc, segment, sector, etc. and many more. Let us recall, before we start our topic of 10th class, let us recall all these important terms. If we take a circle, this fixed point is called center. Fixed distance, distance between the center and any point on the circle is called radius. If we take 2 points on the circle, let us take P and Q. If we join these points and line joining these points passes through the center, it is called diameter. So here PQ is diameter. But in case we take 2 points and the line joining these points is not passing through the center, in that case it will be a chord only. So ST is a chord. Or what we can say is that PQ is also a chord. So chord that is passing through the center is called diameter. Diameter is the longest chord of the circle. Now this portion which is being enclosed by this arc is the portion of the circumference. Any part cut from the circumference is called arc. So the area enclosed between the arc and the chord is called segment. Now we have obtained 2 parts. When we draw chord, we have obtained 2 parts. This one is the smaller one, small part, and this one is bigger part. Smaller part is called minor segment and the bigger part is called major segment. If you move from S to T and if you move from this side, whatever portion is being enclosed, this is major segment, bigger part. Segment means part. Next we have studied about sector. If we take 2 radius means PO and OA are the radii, and this we have taken arc. So the area enclosed between radii, 2 radii and the arc is called sector. This is what we have already studied in 9th class. Now we'll come to next topic that we have to study in 10th. Tangent to a circle. What is tangent to a circle? It is a line that intersects the circle at only one point. Now question comes, how many tangents a circle can have? The answer would be, at one point a circle can have only one tangent. Like if I have taken this point, this is the only tangent that can be drawn. But on a circle we have many points. Like if I take one more point, you can take here. Then from this point again one tangent can be drawn. Take one more point. One more tangent can be drawn. Another point. One more tangent can be drawn. So ultimately what comes to us is that for a particular circle, we can have infinite number of tangents. Many. Or we can say infinite. So you have to read your question carefully. If they ask from a single point, how many tangents can be drawn? Then your answer would be only one tangent. But if they say how many tangents a circle can have, that means they are not talking about a single point. They are saying how many tangents a circle can have, then your answer would be many. A circle can have many tangents. If we take a circle and a line, let us name the line as PQ. If we take a circle and a line PQ, two possibilities occur. This line is drawn, it may intersect the circle or it may not intersect the circle. Intersects or may not intersect. Don't intersect. Let us see how. This is circle. I have drawn this line PQ. In this situation, line is drawn, circle is drawn, but line is not intersecting the circle. That means what? There is no common point. No common point between circle and the line. Second case, when line intersects, if we draw the line, it may pass it like this. In this situation, this line PQ is intersecting the circle with center O at a point, let us name as point A. Here what we have seen, here line is intersecting the circle and at a point, single point. So what we have got? We have got one common point. Now question arises, can this line intersect the circle at more than one point? Let us see. If we draw the line like this, the line is coming from within the circle. At this place, this line PQ is intersecting the circle at 2 points, A and B. Here we have got one common point, and in this case we will be getting two common points. Two common points are there. So these are the three situations when we take a circle and a line in the same plane. Either line will not intersect the circle or it will intersect but either at one point or at 2 points. When the line and the circle are intersecting at one common point, in this case, this line is called tangent. Here, this PQ is tangent to the circle. And this point A is called point of contact. Point of contact where circle and the tangent are meeting. And here, when circle and the line are meeting at 2 points, they are having two common points. In this case, PQ is called secant. So, in 10th class, under the heading circles, we will be studying about tangents and secants. Now we will be doing one theorem based on tangents. In this theorem, they say, prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So what is given and what is being asked? We are given a circle with center O. XY is tangent. This is given to us. This is circle with center O and XY is a tangent. Let P be the point of contact. P is point of contact. What we have to prove is, we have to prove that tangent is perpendicular to the radius. This is tangent and this is radius. And we have to prove that tangent is perpendicular to the radius. Means we have to prove that OP is perpendicular on XY or XY perpendicular to OP, one and the same thing. For proving this thing, let us take one more point, say Q. Then come in the structure. Take a point Q on XY and point has to be outside the circle. Outside the circle. Join OQ. This all comes in construction. Join OQ. Now if I mark one point, say S, on this line OQ, what will come? See, it's clearly visible that OS is a part of OQ. So OS is a part of OQ. So OQ greater than OS. OQ is greater than OS. But OS is radius, OP is radius. So can we say that OQ is greater than OP? Because OP and OS are one and the same thing. This thing we have got. So let it be first one. As I have taken this point Q external from the circle outside, I can take one more point. Anywhere we can take. See, we have taken P. We can extend it and take more points. Suppose we have taken R. In all the cases, like in OT, OR, we can write the same result. Here also, OR is greater than OS, means OR is greater than OP. Similarly, if we take more points, OR greater than OP, OT greater than OP. Means if we take any point outside the circle and join it with the center, the line, this joining line would be greater than the radius. So what does it prove? It proves that OP is the shortest side. Implies that OP is the shortest distance. Shortest distance. And shortest distance from the center is always perpendicular on the tangent. Is perpendicular on x. Hence, proved. since all the lines are greater than this radius, or you can say it like this also. This is longest line. So angle opposite to it would be 90, and sum of other two angles will be 90. Means in all the cases this angle will be greater than the sum of other two angles. Means, and sum of three angles is 180. In this way also you can do. So OP is perpendicular to tangent. Next theorem. In this theorem, the lengths of the tangents drawn from an external point to a circle are equal. This thing we have to prove. So what we are given? We are given a circle with center O. A point P is given outside the circle. Let us take this point here, and two tangents are drawn from this point. Two tangents are drawn from this point on the circle. Let us take R and Q. This is also given that PR and PQ are tangents to circle, are tangents to the circle. What we have to prove? We have to prove that length of the tangents are equal. That means we have to prove that PR equals to PQ. Let's do some construction part. O is the center. What we'll be doing is we'll be joining OR, OQ and OP. Join OP, OQ and you have taken, yes, OP, OQ and OR. Now here we have to prove that this RP, PR and PQ are equal. So this we will be doing with the help of congruency. How? First of all, if we take OR and OQ, these are the radii. So which triangles will be taking? We will be taking triangle OPR and triangle OPQ. In triangle OPR and triangle OPQ. This triangle and this triangle. Here, first thing, OR is equal to OQ. Radii of a circle radius are equal. Then, in theorem 10.1, we have done that angle framed between the radius and the tangent is 90 degree. This angle ORP is equal to angle OQP, each 90 degree. This angle is 90 degree, and moreover OP is common. OP equals to OP common. So what three things we have done for proving congruency? One thing we have taken that this OR and OQ are equal radius. Then this angle 90 degree and this OP is common. Therefore triangle OPR is congruent to triangle OQR. Which rule we have used? We have used right angle, hypotenuse and one side by RHS rule. RHS congruency rule. So if triangles are congruent, then by CPCT, this PR is equal to PQ by CPCT, corresponding parts of congruent triangles. This is what it was being asked in the question. They have asked, prove that from a point, if two tangents are drawn on the circle, length of the tangents is equal. So we have proved what was being asked.